Quantum physics is, honestly, one of the most fascinating and mind-bending areas of science. It's the study of the smallest building blocks of the universe, particles even smaller than atoms, and well, it completely defies our everyday understanding of reality. Welcome to Großdenken, my friends. In today's video, we'll explore the top 5 mysteries of quantum physics, questions that have puzzled scientists for decades. These aren't just abstract puzzles. They reveal the strange and beautiful nature of the universe itself. So, let's dive in. But before that, please support this channel grow by subscribing. It would be a great help. Before we begin, let's quickly set the stage. Quantum physics governs the world of the incredibly small, atoms, electrons, and photons. Unlike the predictable rules of classical physics, quantum physics is full of strange behaviors. Particles can exist in 2 places at once. They can pass through barriers they shouldn't be able to cross. And, believe it or not, the act of observing them can literally change their behavior. It's like entering a parallel world where the rules of reality are completely rewritten. Now let's explore 5 of the greatest mysteries in this fascinating field. First up is wave-particle duality. In quantum physics, particles like electrons or photons, those are particles of light, behave like waves and particles at the same time. Here's the experiment that revealed this mystery, the double-slit experiment. When scientists shot particles, like electrons, at a barrier with 2 slits, if they didn't observe the particles, they passed through both slits like waves, creating an interference pattern on the screen behind. But when scientists observed the particles, they behaved like tiny bullets, going through one slit or the other. It's as if the particles knew they were being watched and changed their behavior. This raises a profound question. How can something be both a particle and a wave? And why does observing it change the outcome? This isn't just a trick of the lab, it's a fundamental feature of reality that we still don't fully understand. Next is quantum entanglement, which Albert Einstein famously called spooky action at a distance. Here's how it works. When 2 particles become entangled, their properties are linked, no matter how far apart they are. If you measure the state of one particle, the other particle instantly knows and adjusts its state accordingly, even if they're light years apart. This phenomenon has been experimentally proven, but it really defies common sense. How can information travel faster than the speed of light? Something Einstein's theory of relativity says is impossible. Some scientists think entanglement hints at hidden connections in the universe, possibly through dimensions we can't see. Others believe it reveals something deeper about the nature of reality itself. Third on our list is the measurement problem, which is honestly one of the biggest philosophical puzzles in quantum physics. In quantum theory, particles exist in a state of superposition, meaning they don't really have a definite location, energy, or state until you measure them. Think of it kind of like a coin spinning in the air. It's not heads or tails until it lands. Here's the mystery. When you observe a quantum particle, its wave-like nature suddenly collapses into a single, definite state. But why does the act of measurement cause this collapse? And what even counts as a measurement? Some interpretations suggest that reality itself depends on observation, while others propose that multiple realities exist simultaneously, one for each possible outcome. It's a mind-bending question that, honestly, philosophers and physicists are still debating. Number 4 is quantum tunneling, a phenomenon that seems to break the laws of classical physics. Here's how it works. Imagine you're trying to roll a ball over a hill. If the ball doesn't have enough energy, it won't make it over. But in the quantum world, particles can tunnel through barriers they shouldn't be able to cross, even if they don't have enough energy. This strange behavior is more than just a curiosity. It's essential for processes like nuclear fusion in stars and certain types of electronics, like transistors. Quantum tunneling shows that particles don't follow the predictable paths we see in everyday life. Instead, they behave probabilistically, as if they can borrow energy to make the impossible happen. Our final mystery takes us into the realm of the multiverse, the many worlds interpretation of quantum physics. This theory attempts to explain the measurement problem by proposing that every possible outcome of a quantum event actually happens, but in separate parallel universes. For example, if you flip a quantum coin, in one universe it lands heads, and in another it lands tails. Each time a quantum decision is made, the universe splits, creating a branching tree of parallel realities. This isn't just science fiction. Some physicists take it seriously as a way to resolve quantum paradoxes. But it raises profound questions. Are there infinite versions of ourselves living in parallel worlds? And if so, can these worlds ever interact? While we don't yet have experimental evidence for the many worlds interpretation, it remains one of the most intriguing ideas in quantum theory. These quantum mysteries aren't just thought experiments, they have real-world implications. Quantum mechanics is the foundation of modern technology, from lasers and semiconductors to quantum computers and cryptography. Understanding these mysteries could unlock new technologies, new ways of thinking, and perhaps even new laws of physics. But for now, they remind us that the universe is far stranger than we ever imagined. So, here's a quick recap of the top 5 mysteries of quantum physics. Wave-particle duality. How can particles behave like both waves and particles? Quantum entanglement. How can particles communicate instantly across vast distances? The measurement problem. Why does observing a particle change its state? Quantum tunneling. How can particles pass through barriers they shouldn't cross? The many worlds interpretation. Do parallel universes exist for every quantum decision? These mysteries challenge our understanding of reality and push the boundaries of human knowledge. Which of these mysteries do you find the most fascinating? Let me know in the comments below. And if you enjoyed this video, don't forget to like, subscribe, and hit the bell icon for more mind-bending science content. Until next time, keep questioning, keep exploring, and remember, the universe is full of mysteries waiting to be uncovered.